everyone! If you are new to my email channel, please don't forget to subscribe and click the bell button for more notifications. Today we're going to learn about the principle of mathematical investigation, shortened as PMI. So what is PMI? It is one of the techniques which can be used to prove a variety of mathematical statements which are formulated in terms of n, where n is positive integer. So let us read together all the principles so that we are properly guided as we use the PMI in solving the different problems. So first is, let P of n be a given statement involving the natural number n such that number 1, the statement is true for n equals to 1. Example, P of 1 is true, or true for any fixed natural number. Number 2, if the statement is true for n equals to k, where k is a particular but arbitrary natural number, then the statement is also true. Third, for n equals k plus 1, truth of P of k implies the truth of P of k plus 1. If these all principles met by the given problem, then we can tell that P of n is true for all natural numbers n. So let us apply the PMI with this given problem number 1. So prove using mathematical induction that for all n greater than or equal to 1, this equation. So 1 plus 4 plus 7 plus and so on plus 3n minus 2 equals n times 3n minus 1 over 2. So again, let's go back with the principle. First is we're going to let the statement as P of n. So like this. Then right after that, we're going to prove that P of 1 is true. So how we're going to prove that n equals to 1 is true? We're going to use these two equations. 3n minus 2 equals n times 3n minus 1 over 2. So bring down it here. Then right after this is we're going to substitute all the value of n as 1. So 3 times 1, 1 times 3 times 1. Then simplify, 3 times 1 is 3, 3 times 1 is 3 minus 1. So we have here. So 3 minus 2 is 1, 3 minus 1 is 2 times 1 over 2. Then 1 times 2 is 2, divide 2 is 1. So as a result, they agreed as 1, which means P of 1 is true. Now let us try to use another value for n, and that is n equals 2. So let us going to prove P of 1, which is also true. So again, we're going to use the equation, but this time, if the number of n increases, the number of terms to the left is also increases. What do I mean? So we have now this new equation. So 3n minus 2 plus 3 times n plus 1 minus 2, but on the right side, still the same as n times 3n minus 1 over 2. So where do you think that second term came from? As you still remember that if the number of n increases, the number of terms is also increases. This time, we're going just to add n by n plus 1. Okay, so we have now 3n minus 2 becomes 3 times n plus 1 minus 2. But on the right side, still the same. Okay, so everything will be substituted by 1 on the left side, but on the given formula will be substituted by the value 2. Okay, so 3 times 1 minus 2, 3 times 1 plus 1 minus 2. But here, 2 times 3 times 2 minus 1 over 2. Okay, so simplify. 3 times 1 minus 2, 3 times 2 is 6 minus 2, 3 times 2 is 6 minus 1 times 2 over 2. So we have like this. So we have 3 minus 2 is 1, 6 minus 2 is 4, 6 minus 1 is 5 times 2 over 2. Then 1 plus 4 is 5, 2 times 5 is 10, divide 2 is 5. As you can see, they are the same. In short, P of 2 also true. So we're done with the first step in the PMI. So let's move with the second step. The second step shows that if the statement is true for n equals k, where k is a particular but arbitrary natural number, then the statement is also true. Which means, if the statement is true for n equals to k, then let us suppose that P of k holds that is. So we're going to say that all the n here will be changed into k, like this. So in this case, we already showed to us that n is equal to k is is true. So let's go with the third step. For n equals to k plus 1, example, truth of p of k implies the truth of p of k plus 1, it remains to show that p of k plus 1 holds. That is, we're going to say that p of k plus 1 is also true. So meaning to say, we're going to change all the k by k plus 1. Okay, so these are now all the essential given or essential equations for us to prove this problem using the PMI. So let us have the next slide. So here we're going to bring down the P of 1, which means 3k minus 2 equals k times 3k minus 1 over 2, and bring down the other P of k, which is 2, like this. So why is it we need to bring down at least 2 equation here? Perhaps when we are adding 2 or more numbers, we need at least 2 addends. So right now, we're going to use this equation of P of 1 and P of 2 so that we can prove that whatever the value of n will satisfy the given formula. Okay, so how? We're going to bring down this 3 times k plus 1 minus 2, add to 3k minus 2. Okay, now, in proving a problem or statement using PMI, all you have to solve only on the left side because on the given right side is your formula. Okay, so you're going to do all the process in order to meet everything, and at the end, this equation will be equal to the right equation. So right now is we have 3 times k plus 1 minus 2 plus 3k minus 2. So how are we going to do the the fourth row here? Okay, so let us use this 3k minus 2 as part of the equations. So we're going to equate it into k times 3k minus 1 over 2 because they are equal. So we have now 3 times k plus 1 minus 2 plus k times 3k minus 1 over 2. So here, substitute it like here because they are equal. Now, let us do simplification. When we multiply 3 times k, that is 3k. 3 times 1 is 3 minus 2. K times 3k is 3k squared to the power of 2. 3 times negative 1, k times negative 1 is negative k over 2. So we have here. Then, we have whole number and a fraction. One way to simplify it is do the cross product, then do the operation here. So 2 times 3k is 6k, 2 times 1 is 2, then do the operation plus. As you can see here that the degree is 2. So meaning to say this equation is a quadratic equation, and we're going to arrange it in a descending order, the degree. So it becomes 3 times k to the power of 2, which 6k minus k is 5k will be the next, then add 2. So we have like this. So 3k squared plus 5k plus 2 over 2. Now, recalling our idea about factoring, in order for us to know the factors, so use the factoring method. So one way to at least give you an idea is to go back with this equation. So one factor must be k plus 1. So bring that k plus 1 here and look for the another factor. So what will be the next factor? That is 3k plus 2. How are you going to check it? So you're going to multiply k times 3k, that is 3k squared. K times 2 is 2k. 3k times 1 is 3k. So 3k plus 2k is 5k. And 1 times 2 is 2. So meaning to say, this equation on the numerator is the same as to this equation. So right now, how would you tell that this last row equation is equal to this? Okay, so we're going to bring down k plus 1 here over 2. But here, how can we say that this is the same as to this equation? Okay, try to imagine. If we're going to multiply 3 times k, that is 3k. 3 times 1 is 3, minus 1 is 2. Meaning to say that k plus 1 times 3k plus 2 over 2 is the same as k plus 1 times 3 times k plus 1 minus 1 over 2. Which means that p of k plus 1 holds of for all n which is greater than or equal to 1. So meaning to say, whatever the value of n which is greater or equal to 1 will satisfy this given formula. So that is how we solve problem number 1 using the PMI or Principle of Mathematical Investigation. Thank you and God bless everyone.